The National Electrical Code Section 230.70 states that for services where the meter is more than 6 feet from the panel, a disconnecting means must be provided at the point where the service enters the building or structure. This disconnecting means must be approved for outdoor use and must be installed in a readily accessible location. Now let's discuss the grounding and bonding of the disconnect, which is governed by National Electrical Code Section 250.32b. This section requires that electrical equipment be grounded. This grounding requirement includes disconnecting means such as the disconnect installed for the service entrance. There are different methods for bonding the disconnect depending on the grounding configuration. If a ground rod or other grounding electrode is used, the disconnect must be bonded to the grounding electrode conductor, or GEC, using a bonding jumper. The size of the GEC must be in accordance with National Electrical Code Table 250.66. However, if the disconnect is installed on an equipment grounding conductor, or EC, only, it does not need to be bonded. To understand how this applies, consider this scenario. If a disconnect in a service fails because it was not grounded, then it did not meet the requirements of the NEC. On the other hand, if another service that passed inspection had a grounded disconnect, it met the code requirements. In conclusion, the disconnect in a service that fails should be grounded using a bonding jumper to a ground rod or other grounding electrode. This grounding procedure will ensure that the disconnect is properly grounded and meets the requirements of the NEC. To summarize the key points related to grounding and bonding service disconnects, it is important to understand the requirements outlined in the National Electrical Code, specifically sections 230.70 and 250.32b, as well as table 250.66. Firstly, the location of the disconnecting means is crucial. If the meter is more than 6 feet away from the panel, a disconnecting means must be installed at the point where the service enters the building or structure. This disconnect needs to be approved for outdoor use and easily accessible. Secondly, all electrical equipment, including the service disconnect, must be grounded. This is a general requirement under the NEC. Thirdly, the method of bonding depends on whether a ground rod or other grounding electrode is used. If so, a bonding jumper must connect the disconnect to the grounding electrode conductor or GEC. The GEC size must comply with NEC Table 250.66. Fourthly, an exception exists if the disconnect is installed solely on an equipment grounding conductor or EC. In this case, no additional bonding is necessary. Fifthly, compliance with these requirements is not optional. Failure to ground the disconnect properly can lead to failed inspections and potential safety hazards. Sixthly, grounding should be accomplished by using a bonding jumper to a ground rod or other suitable grounding electrode. Lastly, refer to NEC sections 230 and 250 for detailed requirements and guidance on services, grounding, and bonding. Understanding the difference between grounding and bonding is critical for electrical safety. Grounding refers to connecting electrical equipment to the earth, providing a path for fault current to flow back to the source. Bonding, on the other hand, involves connecting non-current carrying metal parts of electrical equipment together to create an electrically conductive path. Both grounding and bonding play essential roles in protecting people and property from electrical shock and fire hazards. The equipment grounding conductor, or EG, is a critical component of the grounding system. It provides a low impedance path for fault current to flow back to the source, tripping the overcurrent protective device and energizing the circuit. The EGC must be properly sized and installed to ensure its effectiveness. Common types of EGC include metal conduits, metal raceways, and green insulated wires. The grounding electrode conductor, or GEC, connects the grounding electrode to the electrical system. The grounding electrode is typically a ground rod, ground plate, or metal underground water pipe. The GEC must be sized according to NEC Table 250.66, based on the size of the service entrance conductors. The GEC provides a path for fault current to flow to the earth, helping to stabilize the voltage and prevent electrical shock. The bonding jumper is used to connect non-current carrying metal parts of electrical equipment together, ensuring that they are at the same electrical potential. This helps to prevent electrical shock by minimizing the voltage difference between different metal parts. Bonding jumpers are commonly used to bond metal enclosures, metal raceways, and metal water pipes. In the context of a service disconnect, the bonding jumper would connect the metal enclosure of the disconnect to the grounding electrode system. When installing a service disconnect, it is essential to follow the manufacturer's instructions and all applicable electrical codes. The disconnect must be properly sized for the service entrance conductors and must be approved for outdoor use if installed in a wet location. The disconnect must also be installed in a readily accessible location, so it can be easily operated in case of an emergency. Before working on any electrical equipment, it is crucial to energize the circuit and verify that it is energized using a voltage tester. Electrical work can be dangerous, and it is essential to take all necessary precautions to protect yourself from electrical shock and arc flash hazards. If you are not qualified to perform electrical work, it is best to hire a licensed electrician. Understanding the relevant national electrical code sections is vital for ensuring compliance and safety. Section 230 covers services and includes requirements for disconnects, overcurrent protection, and service conductors. Section 250 addresses grounding and bonding, including requirements for grounding electrodes, grounding electrode conductors, and equipment grounding conductors. It is important to consult the latest edition of the NEC for the most up-to-date requirements. Proper grounding and bonding are essential for electrical safety. A properly grounded and bonded electrical system helps to protect people and property from electrical shock, fire, and equipment damage. By following the requirements of the NEC and using qualified electrical professionals, one can ensure that electrical systems are safe and reliable. In summary, when installing a service disconnect, it is essential to consider the distance between the meter and the panel, the need for a grounding electrode, the presence of an equipment grounding conductor, and the relevant requirements of the National Electrical Code. By following these guidelines, electricians can ensure that the disconnect is properly grounded and bonded, providing a safe and reliable electrical system. To further clarify the importance of proper grounding and bonding, it's useful to understand some common misconceptions. One misconception is that grounding is only necessary for safety. While safety is a primary concern, grounding also plays a critical role in the proper operation of electrical equipment. Grounding helps to stabilize voltage levels and prevent equipment damage caused by voltage surges and transients. Another misconception is that bonding is only necessary for metal parts. While bonding is commonly used to connect metal parts, it can also be used to connect non-metal parts such as plastic enclosures to the grounding system. This helps to ensure that all parts of the electrical system are at the same electrical potential, reducing the risk of electrical shock. A further misconception is that any ground rod will suffice. The NEC specifies minimum requirements for grounding electrodes, including the size and type of ground rod, as well as the depth at which it must be driven into the ground. It is important to follow these requirements to ensure that the grounding electrode is effective. It's also worth noting that the requirements for grounding and bonding can vary depending on the type of electrical system. For example, the requirements for a separately derived system, such as a generator or transformer, are different from the requirements for service entrance. It is important to understand the specific requirements for each type of electrical system. When troubleshooting electrical problems, it is important to check the grounding and bonding system. A loose or corroded connection can impair the effectiveness of the grounding system and lead to electrical problems. It is also important to check the grounding electrode to ensure that it is properly installed and in good condition. Regular inspection and maintenance of the grounding and bonding system can help to prevent electrical problems and ensure electrical safety. In addition to the NEC, there are other standards and guidelines that provide information on grounding and bonding. These include standards from organizations such as the Institute of Electrical and Electronics Engineers, or IEE, and the National Fire Protection Association, or NFPA. These standards provide more detailed information on grounding and bonding practices, as well as guidance on specific applications. When designing and installing electrical systems, it is important to consider the specific requirements of the application. For example, the grounding and bonding requirements for a hospital or data center may be different from the requirements for residential building. It is important to consult with a qualified electrical engineer to ensure that the electrical system is properly designed and installed. In summary, grounding and bonding are essential components of a safe and reliable electrical system. By understanding the requirements of the NEC and following best practices, electricians can ensure that electrical systems are properly grounded and bonded, protecting people and property from electrical hazards. Remember to consider the specific requirements of each application and consult with qualified professionals when necessary. The information provided here is for general guidance only and should not be considered a substitute for professional electrical advice. Always consult with a licensed electrician or other qualified professional before performing any electrical work. It's also crucial to stay updated on the latest revisions and amendments to the National Electrical Code, as these can impact grounding and bonding requirements. Code changes occur regularly, and it is the electrician's responsibility to stay informed and compliant. Additionally, consider the local electrical codes and regulations in the jurisdiction where the work is being performed. Local codes may have additional requirements or restrictions that are not included in the NEC. In conclusion, proper grounding and bonding of service disconnects is not just a matter of code compliance but a fundamental aspect of electrical safety. Understanding the relevant NEC sections, using appropriate materials and methods, and staying current with code changes are essential for ensuring the safety and reliability of electrical systems. Always prioritize safety and consult with qualified professionals when needed.